Okay. All right, so I'm going to go over this now, and I'll go over it again at 9:30. So today, basically, at the 9:30 class, continue on, finish up 02. We'll get a look at the 03. That'll be good. Continue with 0304 on Friday. First quiz is at the end of class on Friday, starting at 10:30. We'll get out at 10:45. It's two problems, two conversion problems. Quizzes are open note. You have a quiz prep that has 6 problems on it. We're going to go over other quiz, any quiz questions you want to see. Anything you ask me to do, I'll do. It's all open notes. You have examples to draw from. The only thing I'm not going to supply for you is conversion tables, but I gave you a chart of conversion tables on Monday. Okay. First quiz at 9:30. You got until 9:45. You've got to be done at 9:45. Okay, 10:45, because there's another class that comes up. So measurement, 2 questions. The quiz prep was posted. I sent it with actually I emailed it Monday night, and I posted it in the announcements. Then, after class is over, you have access to the second quiz for chapter 0. It covers 0.1, 0.2. It's 5 problems. There's more than that on the practice quiz, because you get extra practice on all the types of questions. So there's 1 practice quiz prep, 2 PVs quiz prep. You get 5 opportunities to try that quiz prep, so you know how to do a quiz on Pearson. Because if you mess up when you take the actual quiz, that's on you, because you didn't practice. Now you can quiz prep for it. Okay? You get 2 chances at the quiz, and that's just because it's our first Pearson quiz. I'll get the best of the 2 scores. Okay? The quiz prep was posted already. It's up there. Those are examples of your quiz questions you're going to see. Exact examples. I just changed the number. If you need to see how to work the quiz prep or how to work the quiz, we did a run through on how to do a quiz on Pearson on Monday. You'll see the Math 4P video from Monday. The quiz will be available to you to start at 10:45 Friday. It's due by 5 p.m. Sunday. Okay, so you have basically 2 days, a little bit more than 2 days to do it when you count hours. Any questions? Now at 9:40, 9:30. What time do you think starts? I will go over that in a little bit quickly, but that is a calendar for this week. What are we doing Monday? Well, figure it out by Friday. See how far we get. And I know that the due date for our homework right now is next Friday, which means the test is supposed to be next Friday. Well, if we're not done with all the material, I'm not going to test you on it. If you've ever had me before, you know that calendar is written in dry erase. You take the erase and I move the dates. So don't panic just because you see, oh, the homework's got to be done by next week. So that's only if we're done with everything and we're going to take the test by next week. That's what you pay attention to. Okay. Everybody shouldn't panic. But if you haven't started homework yet, yeah, you should panic. If you're going to do the Pearson quiz, you can get into Pearson. So, on your quiz, you get the first 5 questions up here. Those are your Pearson quiz questions. On your quiz, the graphing prompt is going to be multiple choice. Now, when we get to an in-class test, you would have to draw by hand. Okay. So first thing you look at here and say, all right, X, say it out loud. It's an inequality. Is that a less than or is that a greater than? So less than. So here's that whole thing that you have to get past. It's not an alligator. It's not the little numbers eat the bigger numbers. It's none of that crap. You're taught to read from left to right. So when we look at this and we read from left to right, X is less than negative 3.2 versus if it's written like this, X is greater than negative 5. Less than, greater than. How do you know the difference? Well, it's left to right. Well, wait a second. Good for you. You've been doing this for 100 years. Ask about how do you know it's from left to right? How do you understand that when you go from left? I didn't know that when I was teaching, when I was taking it. I never understood that. Nobody ever told me it's a freaking language. Nobody ever said, hey, look at that from left to right. So how about left to right on the number line? To the left, are they bigger or smaller? Smaller, but they're less than when you go left. To the right, they're bigger, they're greater than. The symbol, less than, greater than. They look like arrows. So when the arrow's pointing to the left, that's less than. When the arrow's pointing to the right, that's greater than. Those numbers are greater than. These numbers are less than. But here's where it gets all screwed up. What are we doing? We want to know what X is. We're solving this whole idea about algebra so we can solve a problem, so we can solve for an unknown. We write an equation to solve for what's missing. So we need a variable, something to solve for. So we have something like, maybe 3x minus 5 is equal to, let me see, let's go with, making a good number here, 20, let's go with 22. Okay, nice. Let's go with great. Now, if it was equal, 3x minus 5 equal 20. That has only one answer because it's exactly equal to. There's only one number I can plug in that makes this true. Because it's equals. When we solve it, we would add 5. Then we have 3x. Negative 5 plus 5 is 0. Over here, 22 plus 5 is 27. That's multiplication. We undo multiplication with division. We divide both sides by 3. So x is equal to 9. The only number that satisfies this original problem, 3 times 9 is 27. 27 minus 5 is equal to 22. That's what we're looking for. It's an equation, one solution. Now, there are other problems that have 2 solutions or 3 solutions. We're not there. Change it to an inequality. We're always looking for what makes this thing true. We want all of the solutions that make this true. You do the same thing. You get x by itself. So we have 5. And we get 3x is greater than 27. Divide both sides by 3. And we get x is greater than 9. So what that is saying is the solution to that inequality is all x's that are bigger than a 9. Give me a number bigger than 9.
9.5.
Give me a nice one. 10. What's 3 times 10? 3 times 10 is 30. So that's 30 minus 5. 30 minus 5 is? So I have 25 on this side. I got 22 on that side. Is 25 greater than 22?
Yes.
So when you plug in 10, which is bigger than 9, it works. Give me a number that's smaller than 9.
1.
8 is good enough. So I plug in 8. I get 24 minus 5. 24 minus 5 is 19. Is 19 greater than 22?
No.
No. So because 8 is not bigger than 9, 8 doesn't work. The only numbers that make the inequality work are the ones that are bigger than 9. But look at how it's written from left to right, the way you read them. All of the solution, all of the x's are greater than, because it's pointing to the right, that's the bigger way, greater than 9. So if you draw a picture of it, and that's the whole point. All the solutions are greater than 9. So I want you to sit down, take out a piece of paper, and start writing down all the possible answers that are bigger than 9. So 10, 11, 12. What about the decimals? 9.1, 9.2. What about 9.0? What about 9? So there's an infinite. So we can draw a picture. There's 0. Over here, is 9 a solution? No. If you plug in 9, 3 times 9, 3 times 9 is 27. 27 minus 5 is 22. Is 22 greater than itself?
No.
No. So 9 is not a solution. This is where I told you on Monday, I like them. I like both. I like Pearson and Vessel. They use parentheses. When you don't have an equals, they'll use a parenthesis. And then they shade the number line like this, and everything to the right. When I have students do this on a test, they really can't draw parentheses versus a bracket. Their brackets might look like this, and the parentheses might look like that. They're sorry to put this on you, but your handwriting sucks. And I don't know, it's just like it's not a priority. Here's the problem. I have to grade what you. If I can't read what you turn in, I can't assume what you're writing is right or wrong. So I can't read it. I can't give you credit for it. If you want me to read your writing correctly, then take the time to write it a little more neatly. Okay? Here's what I'm going to ask you to do. Instead, when you do it by hand, instead of parentheses and brackets like they do in the book, if it's no equal, we would put a open circle because it tells you it's going to be -5. Everything greater than, we would just shade to the right of the 5. If it had an equals, then we would use a closed circle because it allows the -5 to work. That's not important right now because it's multiple choice. So on the quiz, it'll look like this. So on the quiz, it's going to look like this. -3.2. You have a parentheses. Now this is less than. All of the x's are smaller than this. The arrows point this. All of the x's pointing that way are to the left of -3.2. So the parentheses is going to open that way, and it's going to be that picture. Again, with multiple choice. You'll have 4 choices. You don't see an equals. 2 of the choices are going to have brackets. So it's not those. And when you do multiple choice kinds of questioning, process of elimination. As we go through the semester, and especially when we get to the final, I'm going to try to help you learn how to take a multiple choice without doing the problem. If you can do a multiple choice test without actually doing the question, which is not wrong, it's called thinking. I'm trying to help you to think before you just give up. Eliminate what won't work. There's no bracket here because there's no equals here. So it's going to be the 2 choices that have a parenthesis. So this one is smaller than, it's got to be shaded to the left. So find the parentheses that's shaded to the left. That's the answer. Don't overthink it and don't guess. You are mathematicians. We don't guess. If you want to guess, go take philosophy. Okay? You know that most of the prominent mathematicians throughout history were philosophers as well. Archimedes, Aristotle, Rene Descartes, Isaac Newton, Galileo, Copernicus, all philosophers. Don't make me give you a history lesson. Actually, you'll give me a lot of it. Okay, so first thing, what should I do here? Do the parentheses, but there's nothing I can do. What else is, first of all, how about it? Don't be positive, don't make an addition problem. We want to simplify it before we can actually do the problem. Okay? Every quiz I give you when you're in class, it's always going to say, read and follow directions. When you see this question, read it. Maybe you need to say it out loud. My mother barely, no, I won't say barely. She had a high school education. My mom was born in 1922. Okay. She's still, no, she's not. Passed away. She passed away on her 97th birthday. She did. She had a breakfast burrito, and then that was it. You know? That's so, it's like, but here's the deal. She would always talk about how when she was in school, she would cut class with her friends so she could go and wave to the soldiers as they were going through her town on a train. She went to school so she could meet more. And she would go, her dad was a musician, so every Sunday night, that was when the dances were. And that was her, that's why I'm going to school. That's why I'm going to the Sunday, festivities. But all throughout my life, with living at home and growing up with it, even though she never went past high school, she was always in charge of all the little clubs and groups and organizations she was a part of, whether it be the choir or the Guadalupe Society or the YLI, which was the Young Ladies Institute. Mom, you're 60 years old. What do you mean, young lady? She was the treasurer. She was in charge of the money. My mom could not turn on the solar power calculator. She had, for like a penny. She did all of the math in her head. My parents never spoke Spanish in the house. Never. Unless, they were fighting, but they didn't fight a lot. So none of my 5 brothers or sisters can speak Spanish, except for my oldest sister. She was a bilingual kindergarten teacher in Sacramento. So she actually immersed herself in Mexico so she could learn how to speak Spanish fluently and do her job work. But the reason why they didn't speak Spanish in our household is because when my dad was a kid, who was born in 1917, and came to the United States, if they spoke Spanish, they were beaten in school. So he didn't want that possibility to happen with his own kids. So I have no bilingual for any other language except math. A little bit of thing, but that's about it. Long. Anyway, she did the math, and the only time I actually heard her do something talk Spanish was when she did the math. She would do it in Spanish, and she would I would see her doing it on a finger. But she would do it out loud. And that's what I'm trying to do. Moral of the story. You need to possibly read this, whether it be under your breath, hear a voice in your head, before you start. Staring is not enough. You can't look at the problem and expect it to be done. You're not supposed to look at the problem and come up with an answer just by looking at it. You might need to just read it out loud and then be able to take the next step from there. It'll register a little bit more because some of us are visual learners, auditory learners, kinesthetic learners. We learn in different modes. So if you're an auditory learner, you might need to hear it as you do it. 9/8 minus a -7/4. So when I have minus and negative, it becomes an addition problem. That'll help cue you to the next step. You should rewrite it. 9/8 plus 2 consecutive negatives is now 7/4. Because sometimes what I'll see is you'll look at this and just think, okay, that's now positive, and you won't put positive, you won't put addition, you'll just drop. That's now a positive, and then you end up multiplying. So you have to be very careful as you read the problem. Minus and negative, we're doing a subtraction question, so there's no way this becomes multiplication. Minus and negative, that becomes addition. Now, if you notice, that's the only thing I did on that step. I didn't try to change the denominator to do anything else. I'm not in a hurry. You don't get extra credit for finishing first. Then, since they are fraction, I need a common denominator. So what is the least common denominator when you have an 8 and a 4? 8. 8, good. So I need the common denominator. I need both of these denominators to be 8. That one's done. It's already made. This one can change 4 into an 8. You multiply by it. So if you multiply that denominator by 2, then multiply that numerator by 2. Because 2/2 is 1. So this fraction is the same value as 7/4. 7 times 2, that's 14/8. It's called an equivalent fraction. 14/8 is the same ratio as 7/4. But until I change it to 14/8, I can't add it to fraction. So when you add or subtract fraction, you add or subtract the numerator. This is 9 plus 14 all over 8. Now, do you have to show this step over here? No. 9 plus 14, that's 23/8. You don't have to show this step when you do this. You can go from here to here. I'm showing it because I will get questioned. How did you get 23? You have the numerator. Now, this reduces. You need to reduce it to lowest terms. But 23 and 8 don't have any common factors. So that's good. It's done. And right now, we're not going to worry about it's going to, it's not going to reduce it further. Leave it as an improper fraction. So you understand what I'm saying for improper versus mixed number. 23/8 versus 2 and 7/8. Now, 2 and 7/8 is not wrong. But what if you make a mistake when you convert the correct answer and you want to do this? Now you have a wrong answer. This is good enough. You're right here. You have the right answer. You don't have to convert it to a mixed number. And for the most part, I'm always going to want fractions. When you see when you see in the direction of decimal, that's when you get to use decimal. When we do the conversion with convert, these inches into centimeters or convert the ounces into millimeters or whatever, I put in those directions decimal. So that's the only time you get to use decimal. when the direction is telling.
You demonstrate how you convert it.
So the way we get this would be, okay, how many times can 8 go into 23? So 8 will go into 23. Now, in the tens place, you can't go into 2. They got to go to 1. The biggest number we can multiply by is 2. 2 times 8 is 16. So then we subtract. So can't take 6 and 3, so you got to borrow. That's a 1 now. 13 minus that is 7. 1 minus 1 is 0. So 7 is the remainder. So it went in 2 times evenly with a remainder of 7 over the original denominator. So that fraction in the mixed number, the numerator is the remainder. 8 went into 23 2 times with 7 eighths left over. Okay. All right. On this third one, is the answer going to be positive or negative? That's the first thing I would think of. Negative 3.5 minus 1.8. Negative. And then the other thing is, when you look at it, don't assume, because somebody's going to think it's multiplication. So when you read it, negative 3.5 and then minus a 1.8. You spend 3.5, then you spend another $1.08. So how much have we spent? 5.3. So it's a negative 5.3. And a negative times a negative is going to be a what? It's going to be a positive. So then you know the answer is positive. It use a calculator for anything at any time. So all you do here, you know the answer is going to be a positive, and that's going to equal. But here's what I'm looking for. 1.8 is almost a what? A 2. 3.5 times 2 gives me a 7. I don't have a calculator. But then it's 1.8. So 1.8 is 20 cents less than 2.2. 3.5 times 0.2 is 0.7, 70 cents. So 1.8 is 20 cents less than $2. So this answer is going to be 7.00 minus 0.70. This answer is going to be positive 6.30. Is that right? Or you just put it. This one, negative 9 over 8 divided by 704. Positive or negative answer? Peer up on this side of the room, look over here. Positive or negative? Both. This will be negative. When division comes along, you're going to flip the second fraction. So first thing, you want to rewrite it, negative 9 over 8, and then we're going to multiply by 4 over 7. Now, when you multiply fraction, you go straight across. This is going to be negative 9 times 4 over 8 times 7, and you're going to get negative 36 over 56. And if you punch that into your quiz, it's going to be wrong because it's not reduced. So now we're looking for some factors. What goes into 36 and 56? 4. So this is negative 9 times 4 over 56 is 4 times 16. No, 4 times 14. So the fours will reduce and you end up with negative 9/14. That would be the long way home. Which is good song, band super track. Again, trying to edge it. From the 70s. How can I get there quick? How can I get there quicker so I avoid typing in 36/56? Look at step 2 and step 3. I mean, I wrote out every little step. Every step he takes advantage of. At least 19. I'm sorry, we're going to keep giving you bands that you can never heard. Look at step 2 and step 2. What can I do there that would make the problem go through? Please see. But I don't have to do it, so I can avoid that. It'll be reduced over here. What was reduced? Power. Four. Four was the common factor. What could I have done way back when, step 2? And where did it come from? Where do you see 4 as a common factor way back when?
Before you wrote 36/56.
No, not that. I don't want that.
I know, before that one. Before that.
Before that.
Yeah, step before, on step 3.
Okay.
Or in the 8.
48. You have a common factor, so before you actually multiply it out and make it bigger, reduce it before you make the numbers bigger. You have common factors right here. You have common factors right here at negative 9/8 times 4/7. You can reduce multiplication, numbers that are in the numerator with numbers in the denominator. This is 4 times 1, and the 8 is a 4 times 2. So you have a 4/4 that you can reduce. So in the numerator, you have negative 9 times 1. In the denominator, you're left with a 2 times a 7. But more often than not, I'm just going to see this. All right, 4 goes into 4, so that's a 1. 4 goes into 8 2 times. 9 times 1, so negative 9. 2 times 7, that's 14. You have to be able to reduce fractions. Common factors. Common factors. Okay, this last one. Understand these words when it comes to converting from one unit to another unit, from one situation to another situation. What do you have? What do you want? That's your phrase. What do you have? What are you given? And what do you want? What are you supposed to convert it into? So we are told that we want to go 225 miles. And we're going to be driving at 70 miles per hour. So the question is, how long? How long is that gonna take? So what we need is a formula. When we say how long is it gonna take, we're asking you to solve for what?
Okay.
A little more specific, because this is actually dealing with something that you deal with every single day. If you're sitting here at school and you're gonna go home, and let's say home is 8 miles away, and you're gonna drive at 50 miles an hour, you have a good idea of how long it's gonna take. Because you've driven it so many times. But you know that there's a distance and a speed that you're gonna drive. You can use those numbers to figure out how long. Or you have a distance and how long you want to, how long you want to take to get there, and you figure out how fast you have to drive to get there. If you know two things, you can figure out the third thing. If I know speed and time, I can figure out distance. If I have speed and distance, I can figure out time. If I have time and speed, time and distance, I can figure out speed. It's this one. Rate times time is equal to distance. Okay? Rate times time equals distance. How fast you're driving, your speed, times how long you're driving is going to tell you how far you go. Okay? If you're driving at, let's just use 60 miles per hour, and you go for 4 hours, your distance is going to be, so here's the deal. This is called dimensional analysis. That's how you do these conversion problems. This is the sidebar that I want to do a better job than I've done in my previous classes, hitting it all semester long, because this is your life in chemistry. This is your life in nursing or whatever field you want. Being able to convert from one to another. Think of this as a fraction, miles per hour. This is 60 miles every 1 hour. That's what miles per hour mean. It's a fraction. Miles per hour means miles over hours. How many miles are you driving per every 1 hour? And we're going to go for 4 hours. We're multiplying. That's how we end up with the distance, which is going to be in miles. I want distance. Distance is in miles. So what I have is this. What am I going to do? Am I going to multiply? Am I going to divide? Here's the deal. I want miles only, so I need to cancel out the hour. That means I'm going to multiply the speed times the time. The hours reduce. I'm only left with the unit of miles. 60 times 4, that's 240 miles. I want the final unit to be miles. So I need to figure out how am I going to get everything else to cancel. I want time. What I have is 225 miles, and I have 70 miles per hour. So that's miles over hours. And we want hours. So I have to somehow figure out how to work with miles and miles over hours and get the units to cancel, so I'm just left with hours. 225. Over here, I want hours only. I don't want miles at all. So if I have 225 miles, do I want to divide by miles or do I want to multiply by miles? I want to divide the miles. I want miles on the bottom. So that means 70 miles per hour, or 1 hour. I can also write it as 1 hour, the reciprocal, over 70 miles. Every 1 hour, I go 70 miles. So 70 miles is going to be down here for every 1 hour. That's the question that everybody's, kind of falters on. What do I do? Do I multiply by this or do I divide by this? What do I do? What do I do? I don't know which one to do. You know what you do? What do you have? I've got rate and I've got distance. What do you want? I want time. So I want hours. That means I need the miles to cancel. So the miles part has to be down here, so the miles reduces. What am I left with? I'm left with hours. I'm left with time. 225 over 70 hours. That's what you got to figure out. What do you have? What do you want? And we'll finish that one up at 9:30. Come on back then.
Go on.